We're now in Derivers Review Part 12. Problem number 13, we have implicit differentiation with product rule in the middle, so watch out for that product rule. Derivative of x cubed is 3x squared plus, now we're going to be doing f times g prime plus g times f prime, given that this is f and that's g. So we're going to have 6x times dy dx plus y times 6 plus derivative of 2y cubed, 6y squared, dy dx, don't forget to put the dy dx when you take the derivative of a y term, equal to 0. We're now going to move the non-dx terms to the other side. We have a 6x dy dx plus a 6y squared dy dx is equal to a negative 3x squared minus a 6y. We can then factor out a dy dx on the left, 6x plus 6y squared on the inside, negative 3x squared minus 6y here. We can then divide both sides by 6x plus 6y squared, canceling this part out. We can then reduce by dividing everything by a 3. We could have a negative x squared minus a 2y over a 2x plus 2y squared. AP might on that one put the negative out in front. They sometimes do that. So if I put the negative out in front like that, then I would have x squared plus 2y on top, 2x plus 2y squared on the bottom. In problem 14, we have a product rule with a chain rule. So be very careful with that product rule. Once again, this is f, this is g. We have f times g prime plus g times f prime. Dy dx is equal to 2x cubed times derivative of the outside, don't change the inside, times the derivative of the inside, plus our second function, 8x cubed minus 4x squared to the 7th, times the derivative of the first, which is 6x squared. Cleaning this up a little bit, dy dx is equal to, we have a 14x cubed, 8x cubed minus 4x squared to the 6th power, 24x squared minus 8x, plus a 6x squared times 8x cubed minus 4x squared to the 7th power. We could factor out an 8x cubed minus 4x squared to the 6th power. We could also factor out a 2x squared. This time let's go ahead and do that just so that you get an example of what could happen. So let's go ahead and take out a 2x squared from the 14x cubed and the 6x squared. Let's take out an 8x cubed minus 4x squared to the 6th power, because that's the smaller exponent of those two. We could also, well, no, we won't do that. On the inside here then, we would have a 7x, we would have a 24x squared minus 8x plus, and then we're going to need an 8x cubed minus a 4x squared inside there. So that's the idea of some of the things we could do. We could, I suppose, distribute here and then combine like terms, but you get the idea. In problem 15, we have a chain rule with implicit with product rule again, so watch out for the inside. Derivative of cotangent is negative cosecant squared, don't change the inside, times the derivative of the inside, so x dy dx plus y times 1 is equal to 1. Although we could divide the outside term to the other side, I think it's better if we distribute. So we go negative x cosecant squared xy dy dx minus a y cosecant squared xy is equal to 1. We could then move the non-dy dx term to the other side, canceling this out. That would allow us then to divide this negative x cosecant squared xy to the other side. So let's go ahead and divide that. Negative x cosecant squared xy. So the reason why we like to distribute this term here is because that creates the common denominator over in our finished answer. If we were to divide this term over on the first step, we might have to make a common denominator. In problem 16, we have a basic quotient rule problem. We always square the bottom first. Let's not forget to square the bottom. And then we have the bottom times the derivative of the top minus the top times the derivative of the bottom. We distribute the 3, 24x plus 6. We distribute the 8 and the negative. Don't forget to distribute the negative. So we have a negative 24x, but then we have a positive 48. So dy dx is equal to 48 plus 6 would be 54 over 8x plus 2 squared.